someone and just kept, like I always had it rotated the other way, and no one rotated it for like 6 or 7 weeks. And then they started rotating this jackass way rather than trying to figure out how to do it the way I had it. They insist on having it right here. I'm tired of fighting with them. They win. Just gonna leave it there. Right? All right, so in chapter, what we did before, we previously in 21, we talked about hypothesis testing, but we didn't actually do one. So let's start exploring hypothesis testing now. So this is going to be 10.2 and 10.3. They are all part of chapter 10 in your homework, so you probably don't give a shit about that numbering right there. 10.2 will be population or proportions, and then 10.3 is on means. So the hypothesis test. I did not bring out the pages again. I didn't bring the copies that I had. I don't know if anyone's in here that wasn't in here on Thursday when we had all the sheets out, the 5 steps of the hypothesis test. 5 steps. Step 1, identify the 2 claims. And label them. You will have an H0 and an HA. H0 always has an equal sign in it. HA can have a less than, a greater than, or a not equal in. Step 2 and 3, the order really doesn't matter at this point. You need to do them both. Does anyone have their page up from?
Yeah.
What's step 2 say for you guys? Let me stick to that order. Yeah, that's what I have on my notes too. Okay, good. So find the test statistic. And the p-value. Which they didn't use p-value because p is for proportions and the p and p-value is not for proportions. I don't know what the fuck the p is for. Not proportions. Parameter value, maybe? I don't know. I don't know what p-value is for. But it's called the p-value. We will do this in StatCrunch. Step 3 should be identify alpha. If no alpha is given, alpha equals 0.05. Alpha is usually rarely listed as alpha. It's called the level of significance. Step 4 is really where we actually have to do something on our own other than identifying H0 and HA. we need to compare the p-value to H naught. To not H naught, to alpha. And you will have two possible outcomes. A, the p-val is less than alpha. Why not? Let's throw in the equal to there. B, the p-value is greater than alpha. Okay, there are two outcomes. Both of them were making a decision whether or not to reject or not reject H naught. If the p-value is below alpha, we are going to reject H naught and support HA. If the p-value is greater than alpha, we do not reject H naught. Do not support HA. HA is the claim we're trying to support. It's the new idea. It's the whole, what are we doing this project for? We're trying to see what HA is. An easy way to remember this. If the p-val is too low, reject the hoe. That tells you about A. The opposite is do not do it. Some people wanted a sentence for the opposite. That's all I normally remember, and I just remember to do the opposite if it's not bad. But if you want a sentence for the other one, if it's not too low, do not reject H naught. Do not reject the hoe. And it might help you to know when you don't reject H naught, you do not support HA. And this thing has 3 knots in it. It's too low, we don't reject H naught, and we don't support HA. So not shows up repeatedly in the same idea. Now, if you don't like reject the hoe, the H naught is also called the null hypothesis. Another saying that is commonly taught is if the p-val is too low, the null must go, like go bye-bye, like go away. But that doesn't really it's not the same. Reject the hoe is easy to remember. So you don't like Santa. You're like, oh. Finally, step 5. We will state our conclusion. And this is always a statement about HA. And I'll, when everyone's done writing that, I'll give you, 2 basic sentence structures that work like every time. With very little variation. You memorize the sentence structure, you're good to go. Shelby, it was her Linda's phone, figured it out. I was very proud of myself. She left her phone here.
Yes.
And I waited outside. We left here like 15 till. I waited outside for 20 minutes, seeing if whoever it was would come back. I didn't know who it was, but I knew it was someone that sat in that vicinity because the phone was over there. And nothing. And then so I sent out an email and the phone popped up. And I'm like, it showed up like, you got a message from David Jones. I'm like, oh, can I do this to my advantage? And so I sent an email to the names of the people I sat there in that area. The 2 that were here the latest, Shelby and Herlinda, those were the 2 that were the latest here. And unfortunately, I was a dumb shit and I sent them like one right after the other. So I didn't know which one it was, but it popped up that another email was gone. So I narrowed down to one of the 2 ladies. And then at that point, I was gonna wait for a response. And I forget how I figured out it was Linda. You messaged me, but I had already known it was you. I had already decided.
Yeah, because I saw that email that said you said you left your phone or whatever. I didn't know I had left it.
It was your phone?
Yes.
Yeah, I didn't know you were gonna come back and find the, you found the, like I didn't even know the generator I didn't see the generator here.
Yeah.
So I took the phone with me. I took it with me. I was gonna track her down. It was right before spring break. I'm like, you don't want to be without your phone for 10 days. That's a bad beat.
Did you call her?
What?
Call her niece, because in the chat room.
Oh, yeah, I dialed it.
Because we were in the group.
Yeah, I got a message from someone in the group. So I dialed that number back on my phone and said, I don't know who this is. Someone in your group left their phone. It's not you. Someone else did.
And she was the one that was answering. I know.
There was a doubt.
Oh, my God.
Like everyone had, not it. Oh, nope, it's for Linda.
Yeah.
All right, so what possible statements can we have? So if the p-val was too low, the value is less than alpha. We reject H naught, we support HA. Support means there is sufficient evidence to support the claim and then basically paraphrase HA here. Like in words, whatever words you translate, and oftentimes you can copy and paste directly from the question. Especially if it's typed up already, like in homework it is. When you're working in the real world and you have a hypothesis test, it may be like someone asks you to figure out something. People do this for a living, not just actuaries. I have a buddy that does statistics for a living. Uses software, it's, I don't know, it's sick. And then if p-val is greater than alpha, this is the not situation. And guess what? That translates down into here. There is not enough information. Or not enough evidence to support the claim. That, again, paraphrase HA. I tend to say sufficient, and then instead of not enough, I tend to say insufficient. That's something you can replace that word, those words right there. But if you like the whole not, there's nots everywhere, seeing the not in the sentence kind of makes it easier to remember. It's a mnemonic tool, something that makes it easier to remember. We are going to learn 8 different tests, but the only step that changes is the first one. H naught and HA can be drastically different, as we will see. But after that, you need to plug the shit in StatCrunch. Get the results there. You're going to compare the p-value and the alpha. You're going to make this decision, and you're going to make a statement about HA. Everything stays the same. And your final is like 8 of the 10 questions is knowing how to do this process. And we're doing 8 different hypothesis tests, and there's 8 questions on the final related to this. Guess what? There's 1 of each. When we actually do a review on the final, you can use that to your advantage. Start listing the hypothesis tests and cross them off as you do them. That way, you know what you got left. Okay, let's look at some examples. Is everyone ready? No, I see Kinsey. Shelby's nodding, but she's still writing this. She's fucking with me.
I'm just writing others.
I need you to make, you need a red pen when you're writing other stuff and blue pen when you're writing color code, so you're not fucking with me. All right, so. For proportions. With 1 sample. Our H naught is going to be P equals whatever, some value. Let's call it smiley face value. And HA is going to be P doesn't equal smiley face value, or it could be less than, or it could be greater than. But these 2 are the same value. We also need to have a normal distribution. To do hypothesis testing, which I always abbreviate HYP, because hypothesis is a long word that I'd rather just say the hype. To do the hype test. So if it doesn't say it, we need 2 things to happen. We need, and we saw these before, we need n times p times 1 minus p to be greater than or equal to 10. And we need n to be less than 5% of the population. The results it's going to be based off, it's going to have mu of p is actually just p. and sigma p, which I don't think there's any problems in there that you have to calculate by hand. But this is the formula, and we talked about it like in, I want to say chapter 8. But these are the tests. These have to be true. Or it has to say normal distribution. If all that's good, in StatCrunch, we will do stats, proportion stats, one sample. Now you'll either have the data or you'll have the summary. So at this point, it's either with data or with summary. Is ready for an example? We teachers did this, math teachers did this a year and a half ago. During the pandemic, we had all the online classes. We started switching back to face-to-face. We believe, I don't know what it's at now, but we believe that less than 40% of students wanted face-to-face classes. Stats classes, let's be specific. We didn't check everything, we just checked stats. In fall of 2021, we had the following data. Face-to-face, I'm going to abbreviate FTF. And online. We had Math 21 and Math 21 with support. These values were 135 and 550. These values were, what the hell are they? 254 and 241. So when we do this in StatCrunch, it's going to ask us for, StatCrunch is going to ask for X and N. N is, well, lowercase n. N is our sample size. X is the number of successes. In this problem, I'm going to say that's selecting face-to-face. So what we need to do is figure out what X and N are. This is how the data comes to us in real life. It's not all summarized. So if I add up each of these columns, this is 389. This is 791. And if I add those up, I'll get the sample size. 389 plus 791 is 1180. So that's my N. So I have N equals 1180. My X value is my number of successes, which is the number that's at face-to-face, which was 389. So these were actual enrollments. So what is H naught here and what is HA? I think it's almost easy to figure out what HA is first. Step one was we need H naught and we need HA. It says we believe that less than 40% of the students wanted face-to-face, which means we think the proportion is going to be less than 40% or 0.40. H naught is always the statement of confidence, or is the one that we know ahead of time, not statement of confidence. It's the value that we took for granted, the information we had before. We're going to say it equals 40%. And we want to see if there's enough evidence to support our claim. Okay, so that's step one. Step two is to put this shit in StatCrunch and get the information. Step three is identifying alpha. You guys ready to go check this out in StatCrunch? Are we having fun yet? Yeah, we're having fun. Yeah, we are. We're going to go stats, proportion stats, one sample. Now, I don't have what every student selected by name. I just have a summary of their selections. It was in a table. So we're gonna have to go with summary. The only time you select with data, well, you guys will, if you do a proportion test for your project, you'll have a list of data. And you could actually, if you just type it up in Excel and copy and paste it into StatCrunch, you would probably do with data. And we can address that when you're working on it. But we're gonna go with summary. I said the number of successes was 389. This is remembering shit from when I taught it. Holy shit. I haven't taught this topic in this room for 3 years. This computer hasn't changed. It's got the same numbers. If they're already in there, I'm not typing them in. It's going, you typed this before. Do you want to use them again? Sure. All right, so my proportion I'm looking for is 0.40. We change it on the H0. Notice when I change it on the H0, HA automatically changes to have the right value. The only thing you got to do at this point is make sure you got the right symbol here. We need the less than. That's it. That's all we do. Compute. The value, the test statistic we're looking for is the Z-stat. So I'm going to write that down on the page. The Z-stat equals, I'll just go to 3 decimal places, 4.932. And my p-value says it's less than 0.0001. Notice it gives the sample proportion right here. This 0.3296 is actually 389 divided by the 1180. They're telling you what the sample's proportion was. So the sample had like 33%. 33% of like over 1,000 students wanted face-to-face, which means the rest wanted online. We're trying to see if it's less than 40%. So it showed, yeah, it was 0.329 something, which is about 33%. The problem did not give an alpha. I didn't say what level of significance I wanted. So the level of significance is going to be 0.05. That's the default for when there's nothing listed. All right, so step 4 was compare p-value and alpha. I'm putting pauses in here to make sure everyone has time to write stuff down. My p-value is 0.0001. And my alpha was 0.05. Is my p-value less than or greater than alpha? It's less than. So the p-value is too low, we reject the hoe. And when we reject the hoe, we support HA. And that's what our statement is going to be about. Our statement of confidence will be supporting HA. HA was that the proportion is less than 40%. And that's what it said in the sentence over here. So when I write up my sentence, there is sufficient evidence to support the claim that less than 40% of students want face-to-face statistics classes. Don't know what happened. Want to point out something real quick? That less than 40% of students want face-to-face stats classes. That less than 40% of students wanted face-to-face stats classes. I basically took the wording of the question and put it in the answer and just said whether or not we support that idea. You guys ready for another example? Oh, I wanted to show you guys something else with this in StatCrunch. I told you guys that hypothesis tests were related to the confidence intervals. So let's do a confidence interval right here. Oh, I chose T. The 0.05, when it's, the alpha was 0.05. If it's not equals to sign. Oh my God, 1 second. Hello? Yeah, I'm in class. Can I help you for it? What's the call about? Oh, yeah, it didn't work. When I clicked on it, it didn't work. Okay. Okay, thank you. It's relentless. Okay, I think this part is a little bit easier to say when I'm over here where you can see what I'm writing. When we have less than or equal greater than, we can do 1 minus 2 times alpha to get our confidence interval ranking. When it's not equal to, we just do 1 minus alpha. So alpha here was 0.05. And I'm doing less than, so I'm under the 1 minus 2 alpha thing. 1 minus 2 times 0.05 gives me 0.9 or 90%. That's what I'm going to put in for my confidence interval right now in StatCrunch. So we're showing a connection between confidence intervals and hypothesis testing. We have decided that we agree that there's less than 40% that want online. We have rejected H naught, that 40% is a viable answer. We rejected the hoe. We said 40%, no way. No way is 40% possible. Well, we have a percentage. So let's come back over here and look at StatCrunch and see what happens when I do that confidence interval with the 0.90 like we were talking about. Thanks. I click compute and I get a lower limit of 0.307. I'm going to write this down on the other piece of paper. And I get an upper limit of 0.352. Pulling that information from right here, our confidence interval stuff. H naught is P equals 0.4. Is 0.4 in the number range, 0.307 to 0.352. Maybe it's easier if you multiply by 100. Is 40 between 30.7 and 35.2? No. The P of 40% is not in the confidence interval. That's why we reject it. So that's the link between the confidence interval and the statement hypothesis testing. Our P, the P that we're looking for, a proportion of 0.40, is not in the confidence interval. So we're going to reject it. It's just, it's not likely. That's what's happening there. So as I was saying, 0.40 is not in that interval. So we reject H naught, which was P was 0.40. That's kind of how the confidence intervals and the hypothesis testing ties together. And that's why when you do during in StatCrunch, when you click on proportion tests and you do one sample and you do with summary, hypothesis testing and confidence interval are on the same fucking page. You have to click which one you want because they're directly related, and whichever one you want to do is what you're going to have. Example. Then we'll do means and then we'll be done. So according to minstuff.org, I don't know how old this is. This is an old lecture notes. We'll assume it's still right. 22% of married men have, and they put in quotes, strayed at least once during their marriage. So they be cheating bastards. This is what that says. 22% of married men have strayed at least one time during their marriage. A survey of 500 men married men resulted in 122 cheating bastards. Rather than just writing out that long ass sentence, we're going to jump right to what it is. Cheating bastards. At the 0.05 level of significance, assess the accuracy of this statement. Statement by minstuff.org.
I'm assuming it's true.
We'll find out, won't we? So let's, if 122 cheated out of 500, that's the proportion of cheaters in this group. Cheaters in the sample. And that is 0.244 or 24.4%. So that's not 22%, right? It's not 22%. But it might be close enough that if we had just picked a different sample, we'd get 22%. Like we might have just picked outliers or something like that. We might have picked a few more cheaters than the average population has. That's the idea we're trying to see here. Is it 22% or is it something different? So that's where the hypothesis testing comes in. They are saying that the proportion is 22%. And as a decimal, that's 0.22. Now I know HA has got to have a P and it's got to have, it has to have the 0.22 because that stays the same. I need to figure out what symbol to put in here. what they said was assess the accuracy. What? That's the part right here. We want to do the other part. So if they're inaccurate, what symbol could I use here? It's the not equals. They didn't actually say less than, they didn't say greater than. They just said either you're it or you're not it. They didn't actually say it was lower or higher. They didn't, no, they gave a specific value. We just don't know if they're right. Let's face it, a website called binstuff.org sounds pretty suspicious to me. You know how dumb as rocks men can be. So we now have our H naught, we now have our HA, we know what we're going in. Those are what we're going to need to put in. We also needed to put in an X and an N. But P, remember, is X over N. So X is 122 here. And N is 500. X is the number of people that are yes in the case, yes, I cheated. 500 is the number of people asked. So I'm going to start listing some stuff. Start writing this as an official statement of hypothesis here. Let's do our test. What just keeps beeping? Motherfucker turned it this way. That's why I don't like it this way. Another reason I don't like it this way is it keeps hitting some button over here. It's irritating. So step one, we actually did. I did it on the other page. It was identify H naught and HA. Two is find the test statistic, which we saw in the last problem said Z-stat. We're looking for p-value as well. StatCrunch is going to spit those out. The problem has given me a level of significance. They did tell me what alpha is. Alpha equals 0.05, and it was given info. It's not just the default, it's the given as well. I can't do step 4, which means I can't do step 5 until I do step 2. So when everyone's done writing, we will go over and do step 2. You guys ready? So we're going to go stats, proportion stats, one sample with summary. I had 122 successes out of 500 observations. Said P was 0.22 and HA was not 0.22. We got what we're looking for here. I'm going to write down this information here, the Z-stat and the p-value. And I'm only going to write down 3 decimal places for the Z-stat. Because I'm lazy. P-value, I don't know why I always write it all down. While I'm here, I'm going to go take a look at the confidence interval too. Just, normally we wouldn't do this, but I wanted you to see the relationship between them. This was a not equal to, so we have 1 minus alpha is gonna give us a 0.95. And I have 0.206 to 0.281. So this is like 20%, 20.6%. And this is like 28.2%. Is the 22% inside of that region? Yes. The 22% is inside the confidence interval, so we can't reject it. Our hypothesis test should tell us we can't reject H naught because it's in the group. It's reasonable. So I'm just going to write that lower limit down real quick, upper limit. And then I'll come back over to that over here. So looking at the confidence interval, we see the 0.22 is inside of it. Since it's in the region, we don't want to reject. Don't reject. Because it's in the region. It's a valid solution. We should get that same answer when we do the confidence or the hypothesis test. So here we compare p-value with alpha. Which one is larger here? Is p-value less than or greater than alpha? It's greater than. So it's not too low. Do not reject H naught. Hi, Desiree.
Hi, sorry I'm late. I just got off work.
It's okay. I heard your kiddo speaking. So it's not too low. We're not going to reject H naught. We're not going to support HA. This is what we're going to focus on in our statement of conclusion. We don't want to support HA, which means in this case, there's insufficient evidence that the statement made by minstuff.org is inaccurate.
When you entered the number in the hypothesis, you entered the 0.05, or did you enter 0.5?
Wait, what?
Whenever you did it on StatCrunch, you know the first column that you did. Oh,
Yeah, we're putting in our H naught and our HA. We're not putting in.
Okay.
All right. So. Let's keep going. talk about, oh, look at that, night mode activated. Anyone need that up longer? She's got a boot pin. Is there a color coded sequence to what pin you're, yeah, you're,
Sometimes. You can go ahead, I remember what you were,
you should color code your shit.
sometimes I didn't have a bright colored pen before now.
Everyone else is good, I assume, no one's saying anything? All right, so we gotta, how do we pick our level of significance? Which is our alpha. If we go for something like alpha equals 0.1, this is just, there's some evidence against H naught. Okay. When alpha is 0.05, there's fairly strong evidence. That's our default setting. Sometimes it's pretty important that we are very, very sure we might want something more strict. 0.01 is very strong evidence. And we could even go 0.001. And at this point, it's like overwhelming evidence. For like a not equal to confidence interval, this is like 90% confident. This is 95% confident. That's 99% confident. And that's 99.9% confident. Like we are fucking as sure as we're really gonna get. Okay, so for, that's just not even a segue, it's like just some information to think about. We can also not just check population proportions, we can do this kind of thing with population means. We can do a hypothesis test for one sample based on means. We are going to do in StatCrunch, stats, t-stats, one sample. So like we talked about previously for the proportion, this should be normally distributed. If they don't say it, what you gotta check is to make sure a box plot has no outliers. The stuff in the sample should be independent. It should be a simple random sample. And we want n to be greater than or equal to 30. Assuming that's all the case, H naught is always mu equals something. HA is mu, either it doesn't equal, it's less than, or it's greater than. So it's not a whole lot different than a proportion. It's just a different letter, right? It's representing the mean here rather than the proportion. Let's do some examples. Is everyone ready for some examples? All right. So, assuming that the resting metabolic rate which we will call RMR, or healthy males, in complete silence, like they're resting and it's quiet, it's too quiet, is 5,710 kilojoules per day. How much energy are you burning if you're just chill as fuck and dead quiet, not doing anything all day long? That's a lot of inactivity. They must have done this for time periods that just calculated what it would be for a full day. No one wants to just lay there and do nothing for 24 hours. So researchers question this. Researchers measure 45 healthy males. Who were listening to classical music. Not just classical music, but calm classical music. There is classical music that is not calm. Flight of the Bumblebees is fucking frantic as hell. Some of the music you see in sci-fi movies is classical music, and it's very ominous. It's fucking not calming at all. But let's say they're listening to calming. And they found the RMR to be 5,708.07 kilojoules per day, with a standard deviation equal to 992.05. At alpha equals 0.05 level of significance. Is there evidence? This is a long problem. That the mean RMR of healthy males listening to calm classical music is different than those in complete silence. Okay. So this is a one sample. There's only one group of people being studied. And it's asking about the mean. The sample mean is that 5,708.07. The standard deviation, I wrote sigma, that should be S, is 999.05. And they surveyed 45 people. We want to know if that group is different than the 5,710. So the group we're comparing it to is the 5,710. We're going to use that for our H0. And HAA, they said, is it different? They didn't say less than or greater than, they just said different. Now, do we meet the criteria for the test? They didn't give us the data, so I can't do a box plot. I just have to assume there's no outliers. I can assume that the people in the survey were random and independent. Otherwise, they wouldn't have done this survey the way they did. And N is greater than 30, so we have a good setup that we can use. So let's go through our steps of our confidence interval. Not confidence interval, hypothesis test. The hypothesis test. A lot of shit stays the same. Step one is still H0 and HA. But what they are is just slightly different in these. Rather than having P, we've got mu. Two, we're still looking for a statistic and a p-value. I forget what they call the statistic here, like F or some shit like that, something weird. We also want the p-value here. They did give us alphas. Alpha says 0.05. That's a given level of significance. We're ready for our test. I think it's a T-stat. I mean, it is a T-stat test. They better call it fucking T-stat. There's an F, one of these, when we do it, they eventually say F. I don't have any idea what the F is for. You guys ready? For sure. Linda, you good? You're waving your magic wand, I don't know. All right, so we're gonna go stats, T-stats, one sample with summary. They asked us for the information I already wrote down. The sample mean was 5708. Oops. Sample standard deviation was 999.05. They asked 45 people. And my hypothesis test value here was 5710. And we went for not equal. Always check this, make sure you check it. Let's write down our test statistic and our p-value here. Our test statistic is negative 0.013. And my p-value is 0.9897. Holy crap. The largest the p-value gets is 1. So we got our data there. We're gonna come back over here and we're gonna finish our test. So step 4, we compare p-value and alpha. P-value is 0.9897 and alpha is 0.05. P-value is greater than alpha. So we do not reject H0. We do not support HA. That's my abbreviations for do not reject and do not support. I know if you're a nurse, DNR means something else. My HA was that it's different. My HA was that the classical music group was different than the silent group. And that's the stuff I cannot support. So there is insufficient evidence to support the claim. Then I'm just pulling words from the sentence, or the problem, that the RMR for healthy males listening to calm classical music is different than that of complete silence. And I think I should add one thing in there. I should say that the mean RMR. Because individual people may vary. But the overall average is what we're actually looking at. You guys ready for an example with data? Where we don't have a summary? Maybe I'll link this in Canvas. The next thing I'm pulling, it's in a document. I do not want to type in all the numbers. So let me bring up the document on the screen and we'll discuss it. That's where I did the. All right. According to the United States Mint, quarters weigh 5.67 grams. A researcher is interested in determining whether the state quarters have a weight that is different from 5.67 grams. "18 state quarters are randomly selected, and the data is given here. At the alpha equals 0.05 level of significance, is there evidence to conclude that the state quarters have a weight different than 5.67? So I'm going to write down with the important information here. This was from page 118 in the lecture notes. They are in Canvas, they're in the file section, but I'll show you guys how to get to them later. This is the problem on the US Mint quarters. They said that the mean weight was 5.67 grams. And this is for regular quarters. They want to know if state quarters are different. That's going to be my H naught. That's the prior information. They know the weight of regular quarters. One with good old George Washington. The reason why it might be different is because like they have different images on them. So more shit's raised, some shit's lower in certain areas. It may have less actual metal on the quarters or more metal than the standard George Washington one. So they want to know if the average weight of state quarters is different. So different would be not equal to 5.67 grams. That's actually my step one right there. Bam. Step 2 is gonna give me a T-stat and a p-value. I don't know what they are yet, but they're gonna go in there. And the problem specified alpha equals 0.05. It's given. And there was 18 quarters with data. Rather than writing it down, I'm just gonna copy and paste it. You guys ready? Oh, shit. Son of a bitch. I hit power off. Takes a second. It's like, we will not boot on right away. It's like a fucking fire stick. A fire stick on our TV. If my wife, like, when I get home at lunchtime, I'll go in. She'll usually be like in the kitchen making lunch. She'll have had the fire stick on, but she was away from it for long enough that it went like black screen. I don't know. I come in and turn on the fucking TV to eat something while or watch something while I'm eating. And it happens. I don't know why I still do it, because the light on the TV shows me that it's on. The screen's black, but the light, like a little indicator light, it's blue. I know the TV is on. I still don't look at that light before I hit the power button. And I hit the power button and then I look and go, fuck, it's blue. Now I gotta wait through this power off mode. There we go. So, what I'm doing is I'm gonna copy these and hope to God they paste easily in StatCrunch. Single, oh, nope. I guess we're doing that. And I guess I can copy and drag them all and put them in one row. Damn it. Keep doing it. All right, now I don't need those. I got my 18 quarters in there. That's the old test. Problem we're currently on is stats, T-stats, one sample with data this time. Ooh. With data. I've only got one column with data, so we'll just select that column. The other part is the same. I gotta tell that what hypothesis test we're doing. We are checking for 5.67 grams or not 5.67 grams. And it gives me my T-stat and my p-value. My T-stat is 2.753. And my p-value is 0.0136. So now we can finish our test. We have our p-value. We have our alpha. Is the p-value less than or greater than alpha? It's less than. So less than, if the p-value is too low, reject the hoe. Supporting HA is that state quarters have a different weight. There is sufficient evidence to support the claim that the mean weight of US state quarters is different than the 5.67 grams of regular US quarters. All right, when you're doing the chapter 10 homework, I think there's something in there on statistical significance and practical significance. But I think it's going to take more than 15 minutes to cover, so I'm going to cover it on Thursday. What?
Let's do next Wednesday.
Yeah, you still have time, but if you, like, if you're a go-getter and you get home tonight or tomorrow night and you do it and you get to, is it statistically significant? We haven't talked about it yet.
So for like any of our homework, can we go back and try to get a better score on some of the questions until like seventh semester, or kind of confused on that? Or is like what we have by meeting the like score we get? I thought we could like go back and.
I have it so that you can go back and do it through tomorrow.
Oh. And then for the project that's, Thursday, we have to turn in the names of the leaders. I mean, I don't have any.
The members of your team and
And
what your project's on, really.
then what.
You don't need to have collected data or anything like that yet. If you started already, good. But just, I need to know what you guys are working on, that way I can, oh, guide you if I'm.
The first and last name?
Yes, please. Cause you know, we've got like, there's like 15 Herlindas in here. That's it for tonight. Have a good one.
Okay. So this one is up there with the lessons and we just want to. This very.